The figure 1 shows the change in volume of water in a measuring cylinder when an irregular solid is immersed in it. Given that the mass of the solid is 567 grams, determine the density of the solid in grams per centimeters cubed. As usual, let's look at the scale of the measuring cylinder. This figure shows the level of the water in the measuring cylinder before the solid is immersed, and this one shows the level after the solid has been immersed. Of course, we do agree that the volume of this solid is equal to the volume of the water displaced. To get the volume of the water displaced, we need to get V2 and V1. That is, subtract the initial volume from the final volume. It will give us the volume of this solid. Again, in order to determine either V1 or V2, we need to know the volume represented by one small division on this scale. Now, if this line here represents 0 centimeters cubed, and this is 20, and there are 5 spaces, so in order to get the volume represented by one division, we just need to divide this 20 by 5, and we find that it is 4 centimeters cubed. So when we come to V1, V1 will be 84 centimeters cubed. 84. And volume 2 will be, this is 140, 144, 148, 152. So V2 is 152 centimeters cubed. Of course, the volume of the solid now will be equal to 152 minus 84, and this gives us 68 centimeters cubed. Of course, the rest of it is density is equals to mass over volume, and the mass we've been told is 567 grams. 567 grams divided by 68 centimeters cubed, and this gives us 8.34 grams per centimeters cubed. It's just as simple as that. The marks, of course, will be awarded as follows: reading this volume and this volume, and then finally getting the volume of the irregular solid by finding the difference between the two volumes. The next mark is in this substitution, and the final mark will be in this answer here. So 1 mark here, 1 mark here, 1 mark here. It is important to show your steps clearly in order to earn these marks.